Very good morning, students. So yesterday class we started the example. Like heat is flowing through an annulus wall of inside radius r0 and outside radius r1. So there is a gap between the two radius of cylindrical cell. And what is the main problem in this? Is temperature change with thermal conductivity is changed. So at K0, at inside into the radius, temperature is T0, where thermal conductivity is K0, and at temperature T1, thermal conductivity is K1, and the linearly change of temperature with thermal conductivity is a linear change. K change means temperature change linearly. So they are asked is to develop an expression for the heat flow through the wall at R is equal to R0. Here said that we have to find out the equation for Q0, capital Q0. Capital Q0 is equal to small q0 multiplied by 2 pi r0l. So that we have to develop an expression, capital Q0, heat flow through the wall at R is equal to R. Now to derive all this, we say that there is a control volume in between these two radius R0 and R1. We have to consider a control volume, and control volume having a radius R, thickness delta R, and length is L. Now we have to provide heat balance through this control volume. So heat is flowing, its area 2 pi RL multiplied by QR. Heat flow out 2 pi RL at Q of R plus delta R. No thermal energy produced, so we have to consider this as 0. Then as usual, we have to divide by the constants. So constant terms are the 2 pi delta R and L. All these four are the constant. And then we have to take limit delta R tends to 0. So we take a limit delta R tends to 0. R multiplied by Q of R at R plus delta R minus R at Q of R divided by delta R is equal to 0. Then we say we can write d of dr is equal to R multiplied by Q of R is equal to 0. Then we apply a heat flux equation. Q of R is equal to minus k dt per dr. We apply it. We do the integration of equation number 1, and then we rearrange this, and finally we get k multiplied by dt per dr is equal to C1 divided by R. Now here the example say that thermal conductivity is changed linearly with temperature. So linearly changed thermal conductivity temperature. So K is equal to MT plus C. And now we have two radius. So two temperature, two conductivity. So K0 is equal to MT0 plus C. K1 is equal to MT1 plus C. If we take a subtract of equation 3 and 4, so we find out the value of slope, that is the K1 minus K0 divided by T1 minus T0. And once you put down the slope in any equation, we find out the value of that constant and a value of the constant C, and the constant value we find out it K0 minus K1 minus K0 divided by T1 minus T0 multiplied by T0. Now we put the value of C and put the value of N in equation. We put down the value of K and M and T in equation number 2. In equation number 2. So once we put down the value of it in equation number 2, I get one equation, and based on it, we try to fit the boundary conditions. Then, so as Anupama says, next Monday we have a TP midterm. Before that, please give us some MCQ tips either today or tomorrow. Sure, Anupama. We'll do it today. Some MCQ will do it today, and some MCQ will do it tomorrow. So, we do the integration, and then we have a boundary conditions. Now we go further and finally derive the equation using this one. So I put down the value of the boundary conditions in above equation. So I'm getting the K0 like T is equal to T0. So T0 plus applying boundary conditions in above equation, K1 minus K0 divided by T1 minus T0. T square equals T0 square divided by 2 minus T is equal to T0. So T0 square is equal to C1 ln R of 0 plus C2. Same if you want to put T is equal to T1. So in above equation, if you put T is equal to T1 and R is equal to R, so K0 T1 plus K1 minus K0 T1 minus T0 multiply by T1 square minus 2 minus T0 T1 is equal to C1 ln R1 equal to C2. Now if I this is the equation number 4. So if I subtract equation 5 with equation 6, subtract the equation 5, from 6, we have subtract equation 5 from equation number 6. We get a value of C1 as well as we get a value of C2 from this subtraction, and then if we put the value, so let's get the equation C1. So once we subtract from 5 to 6, C2 will already cancel out. So K0 here, first K0, T0 minus T1. Here the constant value. So plus K1 minus K0 divided by T1 minus T0 multiply by minus T0 square divided by 2 T0 T0 ln R1 minus R0. So ln R0 minus R1 is equal to C ln R0 divided by R. Okay. So we do the subtract of both. Now here both having 2 common. We can introduce 2 here. So 2 can be taken outside from here. So if we take outside of 2, then K0, T0 minus T1 minus side is also coming out from, so it's minus K1 minus K0, T1 minus T0, T0 square minus 2T0 T1 plus T1 square. So 2 will be coming out and C1 is equal to ln R0 divided by, okay. So here T0 minus T1 square. So it's T0 square minus 2T0 T1 plus T1 square. So let's change this one. So if I do this, then K0 T0 minus T1 minus K1 minus K0 divided by T1 minus T0 multiplied by T0 minus T1. Here it's a mistake. It's a, let me do like this. K1 minus K0 divided by 2, T1 minus T0, T0 minus T1 square is equal to C1. And okay, T0 minus T1 square, T1 uh, uh, T1 minus T0. So what we'll do, I will change this side here. So I will make plus here and I will change T0 T1. The T0 T1 here it's square. So finally K0 T0 minus T1 plus K1 minus K0 divided by 2. T0 minus T1 is equal to C1 ln R0 divided by R1. Here T0 minus T1 is common from here. So if I take a common, so T0 minus T1 K0 plus C1 divided by 2 minus K0 divided by 2 is equal to C1 ln R0 divided by R1. So C1 is equal to, we find out T0 minus T1 multiply by here K0 and minus K0 divided by 2. It's K plus K0 divided by 2. So it's K0 plus K1 divided by 2 divided by ln R0 divided by R1. We get a value of C1. So let's put a value of C1 at heat flux R is equal to R0. So finally we get a value of C1. So finally we have a heat flux. They called us to calculate the value of heat flux at R is equal to R0. So Q of 0, it's a heat flux, minus K dt per dr at R is equal to R0 is equal to that we have one equation. The equation number equation number 1 or 2 that we have, that the equation will be the C1 divided by R. So R at R0. So C1 divided by R0. Let's put down the value of C1. So we'll find out the value of Q0. So Q0 is equal to, put down the value of C1, T0 minus T1 divided by K0 plus K1 divided by 2 divided by R0 ln R1 divided by R0 divided by R1. Yeah? Okay. Okay, this is, and we also do the further simplification, like Q0 is equal to, we can write down like also Q0 multiply by area at R is equal to R0 by R0 here. So let's put down the value of Q0 here. So finally we get a heat flux at R is equal to R0. T0 minus T1 K0 plus K1 divided by 2 at R0 ln R0 divided by R1 multiply by 2 pi R0 L. 1 R0, 1 R0 will be cancel out. So finally we have heat flux equation. Q0 is equal to 2 pi L T0 minus T1 K0 plus K1 divided by 2 divided by L. So that is the final equation. I would like to say. Okay. Now you would like to solve, or you would like to give some MCQs. They are the practice MCQ that you may solve, or this type of question may ask during the exam. So let's try to solve the MCQ. Just 1 minute. What type of MCQ may you ask? Okay, Shyam, for the submission point of view, what we'll do, I will tell you some of the questions, like individually. I will tell you some of the questions. So based on it, you have to submit that example. Like I will ask you for 2 to 3 derivations, but that I will tell you within 1 or 2 days. But it's not more than like 2 to 3 pages. So and we have only Viva. Yeah? So submission, we don't have anything. Just I will tell you to submit 2 or 3 pages. One assignment is there. That's not big assignment. That I will tell you. That you have to submit. Just 1 minute. Okay, students. So if I ask you, yes, yes. So, so students, if the questions are like this, if eh, which one is the correct thermal energy production in heat production with an electrical heat source? Option number A, SE is equal to I square divided by KE. B, SE is equal to KE divided by R square. C, SE is equal to KE multiplied by R square. D is equal to AC is equal to I square multiplied by K square. So I make this I make this type of MCQ. So you should know the in electrical heat source theory what will be the value of thermal energy production. So according to it, what will be the correct option? Yes, this type of questions asked. What will be the correct answer for this? Students, what will be the correct answer for this? So these type of questions are there. So you have to see the theory. And in theory, there is a written what will be the heat energy production for identical heat source. And correct option will be the A. SE is equal to I squared divided by K. And for example, if I questions like this, after applying a shear stress, for example, a question like this, after applying the first differential in heat conduction, with an electrical heat source, we get, so once I apply the first differential equation in the electrical heat source theory, then what will be your answer? Now I will not sharing the any MCQ bank. No, with no answer. You have to read the theory. Based on the theory, you have to give the answer. You have to read out all the things we did during the class. So, for example, shear stress, B mass flux, C heat flux, and D none of all of the above. So here we don't require any mind because shear stress will apply for the momentum, mass flux apply for the transport of mass. All of above is not possible, and only the answer should be the heat flux. Done? Kamlesh, I uploaded two to three times transport phenomena book in your group. The one question back, which one will be the dimensionless number? Which one is the dimensionless number? In heat conduction, with a viscous heat source. Viscous heat source. So you have to see the theory of heat conduction with a viscous heat source. So the four number are number A, Reynolds number. Number B, Schmid number. Number C, Brink one number. And equation D, none of above. Or none of this. Then, so you have to see this theory in that one number is there. Then the correct answer will be the Brinkman number. So what I did, all this MCQ, I made it, I generated, and this I paste it in your exam source. You have to read the theory, and the question is asked from this theory. Submission Savan, I will give you assignments, and that assignments 2 to 3 per assignments will be there that you have to submit, Savan. Yes, Savan, you have to submit the assignment. I am giving 2 to 3 page assignment. You have to take a photograph, and then you have to convert it into the PDF, and then you have to send me in mail. Yes, only one. Yes, only one. We don't have to do anything. And Viva will be there. So students, we end this meeting here. Okay. Please, any students is remaining to write down their enrollment number, please write down your enrollment number, and then you can leave the class. No need to stay in class in meeting. Just once you write down your enrollment number, please leave the class.